For thousands of years, humanity looked toward the stars and wondered what existed beyond the familiar planets. That question eventually inspired one of the most ambitious space missions ever attempted. In 1977, NASA launched Voyager 1, a spacecraft built to explore the giant planets of our solar system. Engineers expected the mission to last only a few years. Instead, nearly half a century later, Voyager 1 continues traveling farther than any human-made object in history. Its success began with an extraordinary opportunity. A rare alignment of the outer planets created a natural pathway through the solar system. By carefully flying past Jupiter and Saturn, Voyager could use each planet's gravity as a giant slingshot, increasing its speed without consuming additional fuel. The opportunity was so rare that it would not occur again for generations. After leaving Earth, Voyager quickly headed toward Jupiter, reaching the giant planet in 1979. Everything scientists thought they knew about Jupiter suddenly became far more fascinating. Instead of a quiet gas giant, Voyager revealed an incredibly active world filled with gigantic storms, intense radiation, and powerful lightning. The famous Great Red Spot, visible through telescopes for centuries, was confirmed to be an enormous storm larger than Earth itself. Voyager also discovered something completely unexpected. Jupiter possessed a faint ring system that had never been observed before. That single discovery reminded scientists that even the largest planets could still hold major surprises. The spacecraft then turned its attention toward Jupiter's remarkable moons. Among them, Io completely changed planetary science. Researchers had assumed that small moons were cold and inactive. Instead, Voyager captured evidence of giant volcanic eruptions blasting material hundreds of kilometers above the surface. It became the first active volcano ever discovered beyond Earth. Nearby, another moon quietly hinted at an entirely different mystery. Europa appeared smooth and bright, but long cracks stretched across its icy surface like enormous scars. Scientists realized these patterns could indicate a vast ocean hidden beneath the frozen shell. That possibility transformed the search for life. Instead of looking only at planets, researchers began considering that icy moons might also contain environments capable of supporting simple forms of life. After completing its historic exploration of Jupiter, Voyager accelerated toward Saturn. Using Jupiter's gravity as a boost, the spacecraft reached the ringed planet in 1980. Once again, expectations gave way to remarkable discoveries. Saturn's beautiful rings, which appeared smooth from Earth, were revealed to contain thousands of narrow ringlets constantly shaped by gravity and tiny collisions. The planet's ring system proved to be far more detailed than astronomers had imagined. Voyager also studied Titan, Saturn's largest moon. Hidden beneath a thick orange atmosphere, Titan was unlike any other moon in the solar system. Although the spacecraft couldn't see its surface directly, instruments detected an atmosphere rich in methane. Scientists realized this distant world could experience methane clouds, rain, rivers, and lakes, forming a weather cycle completely different from Earth's. It was another reminder that nature often creates worlds far stranger than science fiction. But Titan also marked the end of Voyager's planetary tour. To investigate the moon closely, the spacecraft followed a trajectory that redirected it away from the plane of the solar system. Unlike its twin, Voyager 2, Voyager 1 would never visit Uranus or Neptune. Its mission was changing. The familiar planets were now behind it. Ahead stretched billions of kilometers of unexplored darkness. There were no more worlds waiting to be photographed. Only the invisible boundary where the sun's influence slowly gives way to interstellar space. Voyager 1 was no longer simply exploring planets. It was beginning humanity's first direct journey toward the unknown. After leaving Saturn behind, Voyager 1 entered the longest chapter of its remarkable mission. There were no more planets ahead, no scheduled flybys, and no dramatic close-up images waiting to be captured. Instead, the spacecraft began traveling toward a place no human-made object had ever explored. For years, Voyager moved steadily through the outer reaches of the solar system. Every day, it drifted farther from the Sun, while the signals it transmitted became weaker and took longer to reach Earth. Eventually, a message from Voyager required more than 20 hours to travel in one direction. Despite the enormous distance, the spacecraft continued collecting valuable scientific information from an environment completely unlike anything previously explored. Then, in August 2012, history was made. Voyager's instruments detected a dramatic change in its surroundings. The stream of charged particles flowing outward from the Sun suddenly became much weaker, while energetic cosmic rays arriving from deep space increased sharply. Scientists concluded that Voyager had crossed the heliopause, the invisible boundary where the Sun's protective influence ends and true interstellar space begins. For the first time, humanity had reached the space between the stars. The discovery surprised researchers. Many expected the transition to occur gradually over a vast distance. Instead, Voyager observed a relatively sharp boundary where the surrounding environment changed much faster than anticipated. Beyond this point, the spacecraft entered a region shaped not by the solar wind, but by the magnetic forces and particles of our galaxy. As Voyager continued its journey, it detected faint plasma waves moving through extremely thin clouds of ionized gas. Although space is nearly empty, it is not completely silent. These waves allowed scientists to estimate the density of matter floating between nearby stars. Every new measurement improved our understanding of a region that had existed only in theory before Voyager arrived. The spacecraft also revealed that the magnetic field surrounding interstellar space was stronger and more organized than many earlier models had predicted. These discoveries continue helping researchers refine ideas about how our solar system interacts with the Milky Way. Yet perhaps the most astonishing part of Voyager's story is the spacecraft itself. Designed in the 1970s, it still operates with technology far less powerful than even the simplest modern electronic devices. Its electricity comes from radioisotope generators that slowly lose power every year. To extend the mission, engineers have carefully switched off systems one by one, preserving only the instruments most important for scientific research. Even after decades in space, Voyager continues to send information across billions of kilometers with extraordinary reliability. The mission faced one of its greatest challenges in recent years when engineers temporarily lost readable scientific data due to a computer memory problem. Because radio signals require nearly 2 days for a command and response, troubleshooting became an incredible test of patience and engineering. After months of careful analysis, mission controllers restored normal communications, allowing Voyager to continue exploring the unknown. Today, the spacecraft is traveling through interstellar space at more than 60,000 kilometers per hour. Within the next few years, its remaining electrical power will gradually fade, and its scientific instruments will eventually fall silent. But Voyager's journey will not end. Long after communication with Earth is impossible, the spacecraft will continue drifting through the Milky Way for millions of years. Attached to its side is the famous Golden Record, a collection of music, greetings, natural sounds, and images from Earth. It is a small message from humanity, carried into the darkness as a symbol of curiosity, exploration, and hope. Voyager 1 reminds us that some of history's greatest discoveries begin with a simple decision to explore. Its mission has expanded our understanding of the solar system, revealed the true nature of the boundary between our Sun and the galaxy beyond, and shown that even after nearly 50 years, exploration still has the power to surprise us. As Voyager disappears deeper into interstellar space, it carries not only scientific instruments, but the enduring spirit of human curiosity, continuing a journey that may outlast civilization itself.